Hi, everyone. We'll get this webinar started in a few minutes. There was close to 100 people that signed up for the webinar, so just give a little more time for people to sign on. And we'll start. Thank you. Hi, Gordon. Did you want to start the introduction to Beth?
Yep.
Okay.
Yep, that sounds good. I can get my video going. There we go. Hello, everybody. I just wanted to welcome you all to the Society of Wetland Scientists webinar series. We're glad you could join us today. My name is Gordon Shaw, and I'll be the moderator for today's webinar. I'm a member of the webinar planning committee. I mostly help with the international webinars, but today I get to help with one of our English webinars. I work as a wetland scientist and a permitting specialist for Burns & McDonnell and based in Kansas City, Missouri. We'd like to thank our webinar sponsors for this year, Davey Mitigation, SWCA Environmental Consultants, and RES. And now we're excited to share today's webinar. Today's lecture and topic will be is titled "Long-Term Resilience of Surface Height on Floodplains." And it's my pleasure to introduce our speaker today, Beth Middleton. Beth is a past president of the SWS and is currently the section chair for the Global Change Ecology. She is a fellow of the SWS and the National Conservation Institute and a past Sigma Xi distinguished lecturer. Before joining the U.S. Geological Survey as a research ecologist in 2002, she was a full professor at Southern Illinois University in plant biology, in the plant biology department. She won the SWS Merit Award and a U.S. State Department Eco Partnership Award for her work in Dongting Lake, China. Her worldwide research is on ecosystem function with a focus on geographic change in wetland processes across environmental gradients. Her Ph.D. is from Iowa State University, where she conducted research on the Ecologist National Park in India. Her master's degree is from the University of Minnesota, Duluth, and bachelor's degree is from University of Wisconsin-Madison. She's a master gardener and wetlands and gardening keeper connected to the land. Thanks for joining us today, Beth. Do you want to go ahead and take over?
Sure. Can everyone hear me? Yeah. Gordon, can you hear me?
I can hear you fine.
Okay,
yep.
Great. Okay. So I was really pleased to be asked to do this presentation by the webinar committee, and it presented an opportunity for me to do my first talk on the surface height changes that I've been seeing on floodplains across the southeastern United States. And I am really excited to talk about this. I've found some things that have really surprised me, and I would like to also connect that to some of my ecosystem studies that I've been doing in my long-term research sites. So if I could have the next slide, please. Some of the things that I found that surprised me were, for example, that the ground surface height, I mean, of course, can either increase, decrease, or stay the same. But what really surprised me, I guess, was that I found along the Mississippi River, for example, the inland floodplains were decreasing, at least some of them, along on the floodplains of the river and its tributaries. And this was especially the case along altered river channels where, for example, if a river is straightened or a stream is straightened, it causes the flow to be put into a single channel. And what happens then is that the stream or river channel begins to downcut, and materials are then transported also from the floodplain into the channel. And the reason that happens is that the channel, it happens increasingly, is because the channel downcuts once it's been straightened, because this unit stream power increases as the water flows faster. Of course, the reason that many of these floodplains or many of these rivers were channelized was to dry the floodplains so that they could be developed for other usages. But in these days, some of these floodplains have been abandoned from these usages, and we are now struggling to try to find ways to do conservation in these areas, even though these floodplains are changing so much. And so one of the reasons that surface height decreases is because of the channelization and changes in the riverway itself. Surface height might also increase, or it might increase instead of decrease. And that happens if there is a lot of sedimentation for various reasons, and we'll go into later why that might happen. And also because if the plant production is really high because the trees are growing in a very healthy way, there may be organic matter buildup on, and this happens in both coastal and inland settings. So the when the ground height changes in an elevation, it can cause a situation where the floodplain dries out more frequently, and that's what actually these were developed to do. But it can also increase the flooding and the flood flow in the channel so that it may be very flashy. And it really does change the hydrology on the floodplain itself when you have these changes going on. At the same time, over decades of time, the precipitation levels may be changing. And so what might have been true 100 years ago when some of these river channelization projects were done is now in a situation where the precipitation amounts are very different. So sometimes it's difficult to predict what you would get. And I think sometimes it's also very locality and situation dependent. Okay, so Tamara, if I could have the next slide. So I have some examples, and I'm going to give you a thumbnail sketch of what we're going to talk about first. I have some examples of where there's been a downcutting river and elevation loss along the river. And one is along the Cache River in southern Illinois, where I've worked for decades. And the water gauge people that run the Foreman gauge in southern Illinois found that between 1971 and 1997, there was 6 meters of downcutting in the river channel. And this was, I think, probably also related to the relatively high levels of surface heights on the floodplain themselves. And I measured between 2005 and 2021 up to a centimeter per year of decrease in surface height, which is really surprised me. This was one of my big surprises in doing this work. And then looking into the literature, I found that this was also the case in West Tennessee, where there's been 6 meters of downcutting in a stream that was engineered in re-engineered in less soil. And then there are also reports of this in the Carpathian Mountains. And so I'm not sure how worldwide a phenomenon this is, but it could be a widespread problem. One of the things is that I know when I was putting in the surface elevation tables in starting to do this in 2005, people said, why are you doing this in the inland river systems? Because it's really a coastal technology. And I thought, well, I'd just like to find out what's happening. And so I was actually very surprised to find this. In the coastal settings, I do have a number of SETs in that region as well. I'll show you a map in a little bit, but there I documented a peat collapse event following Hurricane Sandy. And this happens when the decomposition rates exceed the peat production in the sites. And so because of saltwater intrusion. Okay, so next slide, please. So in a nutshell, why floodplains gain surface height is that plant production exceeds decomposition or sedimentation exceeds erosion. And also sometimes there are some cases now of dredge spoil being applied to floodplains to try to bring the elevation up. And we'll talk more toward the end of the talk about some solutions to problems, and we'll talk about some of my experiences with that particular technology. And so some examples of where I've seen height gain are for example, in Belize, the root accumulation of mangroves is actually what builds the islands in offshore in Belize. So these are built on accumulated peat comprised largely of roots. So that's a situation where you have plants growing well and you have an accumulation. You might also have a large amount of sedimentation from eroding uplands. The work that I've done in Dongting Lake with Beijing Forestry, Lake Ting, is indicating high amounts of sedimentation. And then dredge spoil application. I'll talk about that project later. Okay, so next slide. So the direction of the talk, I always like to begin talks this way so you know kind of where I am in the talk, but I'm going to talk about how to do ground height surveys with surface elevation tables. And then I'll go back to these examples that I just presented very quickly and talk about some examples of how surface height change has been occurring, and then how it relates to some of the ecosystem dynamics in each of these swamps. And then toward the end, I'm going to talk about some ideas for potential solutions to the problem, especially of surface height loss. That is one of the bigger problems involved with this discussion. Okay, so next slide. Okay, so where I have been working on these ground height surveys is in my network, and many of you have probably heard me talk about the network before, but you haven't heard me talk about these surface elevation tables in this way. So the first ones I set up were along the Mississippi River from Illinois to Louisiana. And then the next set I put in was between Big Thicket, Texas, including South Louisiana and Florida. And that was set up to be a salinity gradient, with Texas being the most arid and most drought prone. The idea with it along the Mississippi River was that it is a latitudinal gradient, and looking at the initial results of the study, I'm not sure that latitude has much to do with it, but I'm still working on that data set. And then I've also been doing surface height change studies in the Delmarva Peninsula following Hurricane Sandy. Okay, next slide. I'm not certain, and in fact, I'm sure that not all of you know what a surface elevation table is. So I'd like to describe, what these are. And it's a technology that was designed by USGS researchers, Cahoon and Lynch, to determine how height changes are occurring in wetlands. And so what this involves is, in terms of a cypress swamp, it's finding a place that you can actually put it in. There can't be too many knees, and then, if possible, randomizing those. You essentially create a surveyor's monument by driving a series of rods into the ground to the point of refusal. So this is the top rod that's about a meter, and then down further, there's another meter rod and another meter rod. And it just keeps going. You keep pounding them in until you get this thing to stop. And so the idea is that you've now created a point that is unlikely to change very much in elevation. And you can use that then to determine what's happening to the surface height of the swamp. So on top of this monument, then you place the set arm, which is what this is, and you level it and you lower pins to the ground in 4 different directions. And you determine over time, we usually go out there about once a year, determine over time if the elevation or the height is going up or it's going down. And I put this out, the RTK, which stands for real-time kinematic positioning, I guess. But anyway, what this thing does is it communicates with the satellites and tells you where you are elevation. Well, it tells you where you are and also tells you what your elevation is relative to the rest of the world. And this is great. This is an absolutely great thing, except that it doesn't really work well in swamps because of the canopy coverage of the trees, even often in the middle of the winter. So we did also do some leveling, which is just grueling work, especially in a place like Snake Hole, where you practically have to rappel down a rock to get into it. So it's getting the actual elevation is and put on into a global sense is difficult, which is one of the reasons that I'm calling this ground surface height, because it's not, they're not all tied to, and they are relative to themselves, but maybe not to the rest of the world. Okay, so next slide. Okay, so this is a schematic of what the surface elevation table and the set arm look up close. The monument is surrounded with cement so that it keeps it from moving in any direction. And then this arm is placed on top, and then you measure the rods and their distance above the arm to do the determination of whether or not the ground height is going up or down. Okay, next slide. So in the Cache River, and I guess this is one of the first places I put in the sets, and I was completely surprised by what I found there, because in fact the surface elevation was dropping, and it was dropping by, in some places, almost a centimeter a year. So that was actually my real surprise in all of this, and it goes along with the idea that there is a downcutting of the river near the Foreman Gauge. And I think the key thing is that there was in 1916, so this was, almost 100 years ago, no, it's more than 100 years ago, there was a push to develop this area, particularly for agriculture. And so an attempt was made to drain it by diverting the Cache River from its normal course directly into the Ohio River. And when that happened, the river began to downcut, and it's downcutting to either the level of the bedrock or to the Ohio River. And it's been many meters downward, and it's just going to downcut until it reaches some point of equilibrium. And we also put down feldspar markers at these sites, and we found that there was really very little sedimentation at our sites anyway. And so most years there was less than 1 millimeter of sedimentation. So that's not offsetting this down cutting. Okay, next slide. Oh, that's published in an ecohydrology paper, by the way. Oh, can we go back? Okay, so so that's the situation in inland wetlands, or at least some of the inland wetlands I've worked in. The reason that surface height is lost in some of the coastal wetlands is because of salinity coming in during storms and for other reasons, and then it causing the trees or vegetation to become unhealthy. And when they cease producing enough materials, particularly wood or roots, the peat begins to fall. And so that was what we saw at Hickory Point Swamp, which is in Maryland. So could I have the next slide? So so I want to give you a few more details of what's happened in each of these particular swamps I've been talking about. And so in the case of the tidal swamp in Maryland, Hickory Point, after Hurricane Sandy, we got out there. We finally got the equipment and the funding together, and we got out there, and with our water level recorders, we found that in the successive hurricanes and offshore storms, there were peaks of water and salinity. And when there would be a storm, there would be, and I don't know, Tamara, if you could like point at these two peaks on the rooting zone salinity. Yeah, here we go. Hurricane Melissa, the one down below. Yeah, there you go. Hurricane Melissa rooting zone salinity was similar to the surface water level increase during that storm. And then there was an offshore storm that didn't have a name in 2021. That's to the right. It's okay if you don't see that one, but the same thing happened. And so we think that what's happening is the rooting zone salinity is rising during these offshore storms, and then causing the cypress trees to become stressed and then eventually die. Okay, so next slide. So here are some data looking at what we thought was going to be a study looking at the growth of trees, and it started off that way, except that immediately a few of the trees began to die, and then they all stopped growing after some period of time. So and looking out into this forest now, instead of seeing cypress trees, what we're seeing is a profusion of cattail and Phragmites growing in. And so it's the vegetation is shifting to species that are a little more salt tolerant than Baldcypress. And that's published in an Eco Indicators paper in 2022. All right, so next slide. So what this has to do with surface elevation is that at the same time that the vegetation was becoming stressed and dying, we noted based on our surface elevation table measurements that the peat began to collapse. And so between 2015 and 2021, and the two lines represent the surface elevation table heights, ground surface heights, that at one of them, the surface elevation dropped by 50 centimeters, and the other, it was about 15 to 20 centimeters. So there was a great deal of peat collapse. What happened when the trees began to die was that the amount of degradation of the plant, the organic matter, exceeded the amount that was being produced, and then it became kind of soupy and now is reverting to a different kind of wetland. Okay, so next slide, please. So that was bad news. I think it might be one of the first times that an entire peat collapse event has been actually recorded in that way. And so that is a useful study. But another study that we did was following Hurricane Katrina in John Lafitte National Park, which is near New Orleans. And so right after the storm, again, we didn't get out there right away because we never get funding and equipment organized immediately. But we noted at our surface elevation tables that the surface elevation where it says before remediation was dropping. And then, and Tamara, if you could point at the graphic, yeah, there you go. And then after remediation, the levels of surface height went up for a time. And this remediation event had to do with, first of all, there was in 2010, there was a lot of rain, but it also preceded the diversion of water to push the during the Gulf oil spill to push the oil out to sea. And so we're not sure exactly which of these two things caused the freshening in these swamps, but the trees grew better and the elevation went up, at least for a time. You can see that went down again where the orange characters are, or symbols are in the far right. Okay, so next slide. But I mean, the hopeful thing about that is that it shows that as long as the trees are still alive, it's possible to reverse the situation if you get more fresh water. All right, so I wanted to talk about the surface height change as related to tree production. And we have another study looking at salinity across a gradient from Texas, where it's arid and salty, to St. Mark's, Florida. Actually, in John Lafitte National Park, the salinity levels it's fresher than it is in Big Thicket, and St. Mark's is in between. So if you could show the next slide. So this is measuring the growth of the trees with dendrometer bands. And so this graphic on the lower right shows you the growth of the trees. In Texas, the tree growth is fairly negligible, and it's low because of high salinity. It's medium in Florida, and then in Louisiana, where the water is freshest, the trees are growing the most. And one thing I should point out is that it might not just be salinity. Having more fresh water and moving water in particular will lower anoxia and just make the trees grow better in general. So it's a matter of having additional fresh water. So next slide. So another study that we've done that sort of serendipitously showed the results of adding fresh water was on the trees in Big Thicket, which is a national park and a coastal area, a tidal coastal forest. And looking at the regeneration through the size of the cones. And so there was a drought in 2011 and 12. And at that time, the cones were really, these numbers are a comparison of the size of the volume. And the amount of rain was fairly low during that year. And the size of the cones were about the size of the end of your thumb. And then in 2017, there was this giant hurricane, Hurricane Harvey, which dumped just a huge amount of fresh water on these swamps. We went out there later after the storm had after the stormwaters had gone down a bit, and we saw that there was storm debris in the trees that were at least 10 meters into the canopies of the trees. And so it was really quite impressive. And there's not much good to say about that storm, aside from the fact that after that storm, the cones grew to a huge size. I've never seen them this size before, and they were about the size of small Christmas tree ornaments that year. So that was really impressive. But the main point is that even if you have trees that are fairly stressed, that if they get a big bunch of fresh water, they may revive and grow very well. Okay, so next slide. And this is what these forests look like in 2011 and 12. And we were out there doing dead tree surveys. And I think if you advance it, it'll show you, I think there's yeah, there you go. Okay, so there's what we found in this survey was that the bigger trees actually, the ones that were more than 20 meters tall, actually did relatively okay. You know, I've got this. Oh wait, no, I'm sorry. Okay, yeah, they did better. And then if they were kind of medium sized, many of them died in it. But if they were smaller trees, they died. And so their ability to be revived with fresh water after a drought and high salinity is somewhat dependent on what size of a tree they are. And so there's very much, I think, that we don't necessarily understand about how fresh water might revive trees, because it also depends on what size class of tree we're talking about. Okay, so next slide. So now comes the part of the, is anyone asking any questions? Tamara, I've just been.
No, I have been
What?
monitoring.
Oh.
I've been
All right.
monitoring the Q&A and
all right.
Well,
I used to be a, you know, a college professor, so I'm going to ask you questions if you don't ask questions. But okay.
Yeah, if anyone wants to, I'm monitoring the Q&A.
Okay. All right. And just to remind people, I was just, you know, storming along, not paying any attention. But anyway, I'm open for questions whenever you are. So so I want to talk about some of the solutions. I think what I presented shows that we have some challenges for conservation in these natural areas that are either along downcutting inland rivers or also on the coast, where we may be losing elevation for different reasons. And looking into the literature, there's some very interesting information from the USDA and also other sources that show that it's possible to repair a river channel. In other words, try to put it back up more in contact with its floodplain by doing things like putting logs and rocks. I mean, people remove logs and rocks from rivers, right, to make them move faster. But if you replace logs and rocks, it can cause the water to slow down and cause sediment to build up, and also create more interaction between the channel and the floodplain itself. And so the idea is to encourage the remeandering of the river, which would benefit ecosystem processes in the floodplains. Okay, next slide. On the coast, there have been some very interesting work showing that freshwater release can reduce tree stress, especially if they've experienced drought or low oxygenation for some reason, and especially salinity. And if you could push forward, it's gonna circle yeah, there you go. Just stop. So I talked about the situation at John Lafitte National Park, where there was 4 months in the late summer in 2010, there was 6 times the normal amount of fresh water, both because of precipitation and possibly because of the diversion for 4 months. And after that, for 2 years, there was 3 times the level of production in those forests. We also saw the example of the Hurricane Harvey at Big Thicket being related to a tremendous increase in the size of cones. Okay, so if you push forward again, yeah, next, there we go. And then and there was a very large drought in Australia, and the Australians decided that to release fresh water. I mean, this is a really good test of this idea. Really, they released fresh water for 2 months into eucalyptus forests, and the trees were very healthy for another year. One of the things that was said about this, though, was that it was really important to give the water before the trees became too stressed and too damaged in order for them to recover. And if you think about an animal that was dying from lack of water, it would be important to give the animal water before it actually became too sick. And so it's a little bit like that. Okay, so next slide. So I have more difficulty seeing a potential solution for certain other areas, particularly if they're in highly developed areas, either from agriculture or urbanization. And unfortunately, Hickory Point is really the fresh water is really in demand there. It's near the Washington, D.C. metropolitan area, and it's also a highly agricultural area. So water sharing can become much more difficult for natural swamps in areas like that. I don't know what the solution is, but it has been sad, certainly over the years, to watch the trees die. It's now become more of a cattail phragmites marsh than a tidal freshwater cypress swamp. Okay, next slide. Another potential solution, this gets discussed a lot in the management world, and that is the idea
Beth,
of,
there is a question.
Oh, okay, I don't see it on the chat. Okay, so
I can read it. Would it
all
be
right,
possible, this is from Evan Dillon, would it be possible to use DTM, digital terrain model, satellite or drone data to increase how much surface loss monitoring you can analyze at a time? I believe there are bathymetric LiDAR sensors that can map underwater terrain.
Yes, I think that is probably possible. I have not used that. I have actually talked to some people about doing that kind of thing, but I would be most interested in pursuing that. And I mean, I'm not sure. So Dylan, is okay. If you want to talk about this offline, I'd be glad to do that. That sounds like a great idea. But and I think it would be a much easier than I think the surface elevation tables are great, but one of the things that is really difficult to do in those swamps is to tie this to elevation, which I think is an important aspect of the question. So I think combining these technologies might be the way to go in the future. Okay. All right, I honestly don't see these questions. Okay, all right, but that's good. Keep asking them. All right, another potential solution is, which is talked about quite a lot these days, is to apply dredge spoil. And along navigable rivers, there is a need to dredge the channels for navigation. And then there's also a need to put the dredge someplace. And it has been shown to be useful in certain kinds of wetlands, but it remains controversial in cypress swamps. So I have exactly one experience with dredge spoil application, and that was in John Lafitte National Park, not in the areas that I was talking about, but in a separate area. And when in that particular work, we had surface elevation tables placed before the sediment was put down, and we noted that there was it was almost a meter of sediment put into the swamp, and that after that happened, by the next year, the trees had died. So I'm not sure what happened. I think it was possible that they just were in very low oxygen a situation after the sediment was applied, but that was not the scenario and the outcome that everyone was hoping for. It is discussed. I think it needs more testing, possibly really small amounts, like a centimeter or so, or maybe more than that. I'm not sure what the limits of how you release it into a wetland would be, but a smaller amount might actually help coastal swamps in particular. And then there's also, actually high levels of sedimentation which just never seems desirable. I mean, it could be helpful in some of these swamps that are losing elevation in inland sites. I'm a little bit doubtful about that in the inland floodplains, but again, that hasn't really been tested. Peat gain, of course, can also happen by keeping the vegetation as healthy as possible. For example, by having high levels of root and wood production. And so I think trying to find ways to keep the vegetation as healthy as possible would be helpful in in moving forward with trying to keep elevation at least at an equilibrium in these sites. Okay, so next slide.
Beth, got a quick question.
Okay.
It's not associated with a name, but it says, does the role of subsidence impact your results?
Yes, they do. And so, and you're going to have subsidence in, you know, various situations. It does, it certainly does factor into, you know, what you're seeing in terms of the elevation over time. So yeah, probably something to add to the beginning where we talk about why elevations go up or down. Okay, all right, good point. So just to summarize, we're getting close to the end of the talk here. So how you promote surface height, a solution to the problem would be a good thing to do would be to address channel incision and try to slow the movement of the water down in the channels. Of course, the channelization was done in the first place to dry the floodplains, but there are floodplains now that we are trying to maintain for usages that are trying to maintain the natural areas, and having this channel incision is a bit detrimental to that. So we also, yeah, I guess I went through a lot of this, but I wanted to say something about water in general. And this comes from my father, who was a farmer. We had some wet parts of the farm next to wetlands. And he said it was always important to give water its space. It needed some place to go. And I think that when talking about draining floodplains and about what to do with water, I mean, I think it's an important thing. It's very useful for wetlands. And so I think we need to view it as flooding is not the enemy exactly. We just need to be able to put it in some place where it's useful, or have it go on its own to some place that it's useful. Okay. All right. So then in the coastal situation, we've already talked about that already, but we want to try to reduce salinity and support freshwater delivery. There's a great lot of freshwater extraction that goes on along rivers. And often by the time the water gets to the coast, there is much less freshwater as a percentage in it than there was probably in times past. So we need to keep that in mind at all as well. We might attempt to apply dredge spoil to raise the elevation. Again, there's a question mark there, because the one time I've seen this done, it did not have the desired result at all. So I think this needs to be approached cautiously and tested extensively. And the one last thing is and I didn't mention this in the talk, but there's also the idea of creating freshwater barriers to keep freshwater above the area where there's salinity in the water. And the freshwater barriers are usually created to protect freshwater resources for humans. And if, you know, they could maybe be positioned in a way where they didn't actually downstream of them actually create a situation where the salinity levels might become more elevated during droughts. And so sometimes the placement of where these freshwater barriers are some thought about this could actually be beneficial for conservation purposes. Okay, so that's you can do the next slide, but that's close to what I wanted to say. I have references. If you look this talk up again, you'll find that I have references for everything, I guess, that I said. At least that was my intention. And some of the papers that I have that's on this topic, but you can find these here. And if you have, okay, there's my email address. Good. If you have questions or comments, or just, want to discuss anything with me, there's my email address. I'm glad to talk to you about this after the webinar in the future. So anyway, so thank you for your attention. I'm wondering now if there are any more questions now.
There are.
Good.
Dan Crows, said I was near a diversion project yesterday and they were charring the slash and burning it. Does biochar help?
Biochar would be a source of carbon. And so I think I don't think this has been tested, but I think it could be something that could be placed on the wetland that would be more organic than in comparison, say, to dredge spoil. Okay. Well, that is a very interesting idea. Okay, sure.
And the little edit there, they were charring slash and burying it, not don't know what I said before.
in the swamp. Okay, well, sure. And I guess it would decompose at least to some extent over the time. Probably the charring would slow that down a lot, but it could create a kind of more of a stable platform. All right. Well, that's a great idea. That's one of the reasons I like to give the talks and webinars, because I get feedback from people about yeah, thanks, Dan. That's a interesting idea. We should talk more about that.
Okay.
I know Dan,
JC,
by the way, so
yeah, good. JC Weaver asked, was the dredge soil tested for contaminants, for example, heavy metals, petroleum, chlorinated solvents? I would expect these chemicals in that type of material.
Wow, I was at a meeting recently and I brought that same idea up. I wondered about that in the project that I was involved with. I'm not aware that it was tested for that, and I am aware though that sediments often do have those kind of contaminants. So I think that is something that needs to be considered with dredge spoil applications for sure.
Great. We have another question. Kimberly Ponzio, she says, thank you, Beth, for your informative presentation. Can you comment on the size and frequency of the pulses that you see as a solution for surface height gain? It's remarkable that just a quick pulse from a hurricane could improve cypress tree health so quickly.
Okay, Kim, I'm not sure. Hi, in fact, hi. I also know Kim. The hurricane pulses that I've seen actually do not necessarily improve the growth of the trees. What I've seen really is that it tends to drive salinity inland and causes the trees to become stressed. So I'm not sure how to answer that question, because I think I might not have made that point clearly. Maybe Kim will respond with another thing in the chat, but yeah, I was surprised at how quickly they responded negatively to having salinity driven into the rooting zone. I wasn't really expecting that. I mean, again, I don't know why so much of I have an idea when I go in to do an experiment or scientific observations of some sort, and I think, okay, I think I know how this works. It's that hypothesis, and when I pose that hypothesis, I think, okay, that's how it works. That's what I'm thinking, and then I get out there and something, a good 80% of the time it just works completely differently than I'm thinking it is. So I'm endlessly surprised at how it really works.
And anybody have any more questions? It looks like that is it so far.
Well,
Hey,
I
Beth.
mean,
Hey,
okay,
Beth, this is Gordon. I do have a
okay,
question I
uh-huh.
wanted to ask you. And this goes back maybe even just to the very basics of this. Um, why is a change or a decrease in the floodplain height a problem?
Well, because at least, and I didn't really go into this, and because I don't know how to answer that exactly. But if the floodplain height is declining and the rainfall is increasing, as it is in southern Illinois, one would expect these wetlands to become more flooded, at least as long as the evaporation levels are roughly the same as they were. So I think that it's also elevation decline occurs on floodplains sometimes, even if there aren't natural areas in the area. So for example, I think it's a problem too for, I mean, I need to talk to a few more farmers about this, but if you have farmland and the elevation is decreasing over time, again, it's likely to become much more flooded. Or if you have buildings or infrastructure on a floodplain, it seems like having the elevation dropping the way it is could be a problem. And if you look at toward the beginning of my talk, I showed over and over again the trees that were down cut. On one side, you can see their roots exposed. Over time, I think what will happen as the floodplain elevation drops toward the channel, and I don't think it's even across the whole floodplain, I think some of those trees will become unstable and fall over for no other reason than erosion. So I don't know. So I think there's several potential problems, but I think it's a largely unstudied phenomenon.
Yeah, very interesting.
Yeah, so I might ask people in the audience if you have, for example, any experience with dredge spoil application. I know it's much more widely tested in coastal marsh settings. I mean, what is your experience with that? I mean, is that uniformly successful? Are there problems with that? I mean, does anyone else have observations on cypress swamp with sediments added? The biochar idea, Dan, is really cool. So, that would be something to test.
Not seeing any comments at the moment.
Okay.
Oh.
Yeah, yeah, feel free
Oh.
to put those comments in there, please. Beth, I think just speaking from my point, I do have a little bit of background in urban forestry, and that is like about one of the worst things you can do to trees is just put some more fill material on top of the roots.
Yeah,
Kills the trees.
right. That's my understanding is that, do you have any experience with putting very small amounts on?
I do not. I know the literature that I've read pretty much says that just about any amount will kill some roots.
Yeah. And, cypress trees have a very hefty set of roots, and, including the knees, which are root material. And so the amount of sediment that was placed in the site that I was working on actually covered almost all of the knees. And so there was pretty much literally no root material really to oxygenate the rest of the tree at that point. So whereas it might seem that a cypress was, is a tree that could stand more, deeper amounts of sedimentation. I mean, this is all, just guessing on my part, but but also since it has those roots, it's actively trying to aerate its, its underground materials. And so, I'm not sure exactly what this is something that I think really needs more study. And it offers some potential for addressing the problem of coastal surface height decline, but what I've seen so far hasn't been very successful. And Gordon, if you actually can share some of that literature that you've seen on various tree species, I'd love to see that.
Yeah.
We've got
I'll see what I can
more.
find.
Oh, thanks. Kimberly Ponzio responded, that's a great point about the knees. That was precisely what I was wondering about, covering them with the dredge material.
So okay, I finally figured out how to see the questions. Okay, okay, so I see from Jeffrey now. Okay, so you've used dredge spoils to restore cropped cranberry bogs, and it has been successful. Great. All right, I think that's the kind of information that we need to bring forward. I think it's I haven't worked in it, but I think from my read of it, it's been more successful in coastal salt and other kinds of marshes. So and I think the point that the dredge spoils ought to be tested for heavy metals is an excellent one. But I think it does offer some potential solutions to the problem.
Great. Yep, it looks like we've got 5 more minutes. Oh, no, Joe Berg says thanks. Thanks. Lots of good information from Joe Berg.
Okay, well, this has been, as I said, this has been fun for me. I haven't really talked about this information before, at least in this way. And I'm trying to look now at my surface elevation tables across the southeastern US and see what the general patterns are. And I think they're probably maybe more localized than I would originally thought. I would have thought that some of the larger landscape patterns were controlling, what I'm seeing. I'm really, it's early days in trying to do the analysis of this, but the patterns are not really popping out at me, but it seems that some wetlands are losing elevation and some are gaining elevation, and the answers to why is probably the answers are probably quite complex. So that could be a parting statement unless anybody else has a question.
Yeah. I don't see any additional questions coming in. So maybe that's it. And then, with additional questions, they can feel free to contact you.
Yeah, absolutely. I would love that.
Well.
And, if anybody has papers and examples and experiences of, related to the things I was talking about, I'd be very happy to see them. Oh, here's something from Jamie Duberstein. It's super expensive. 1 meter of spoil would surely kill almost any tree. Well, I'm not sure that that's the amount to test. I think, and I think the testing should be started at much lower levels. Okay, so he's saying, I know of studies looking at heavy metals in dredge is related to marsh creation. There weren't any notable heavy metals in birds using the area, none high enough to surpass critical levels. Okay, all right. That's okay. Oh, here we go. More questions. Oh, don't go yet. Okay, so does this mean floodplains are sediment starved? Probably not all of them. But the ones that I worked on in Illinois, very surprisingly, so seem to be. And this does not really quite fit what my understanding was of the sediment deposition levels in those floodplains. I also don't want people to generalize this to all floodplains, because I think it's situation dependent. I think if the especially if the riverways are not channelized, then this is much less likely to be a problem. But I think it's one of those things that is underexplored, and so willow will take more than 2 meters. Okay, so thanks, Dan. So sediments on it's not a problem for all of the trees. It makes sense because you see willows in areas along near rivers, like near cropland, and so it makes also sense that there would be sediments coming from the cropland. Okay, interesting.
Yeah.
Well, that's the last question I see now.
Yeah, I think that's same here. I don't see any others coming in. So yeah, maybe this might be a good time to end it. We'll be able to end before the 1 o'clock. We had an hour here. But Beth, we thank you very much for your presentation. Very good information, and appreciate that.
I was definitely delighted to do this. So thank you for inviting me.
Yeah. Yeah. We thank you. We also like to recognize again and thank our series sponsors, and Davey Mitigation, SWCA, Environmental Consultants, and RES. You can find their information at the websites listed before. And we encourage you to visit, like, and follow them. We'd like to also remind you about our upcoming webinars at sws.org. June 17th, we've got AI use for wetland scientists. We also have the annual meeting coming up in Providence, Rhode Island, July 15th through the 18th. And then August will be a to be announced webinar. Please be sure to complete the survey that will be sent to you after this webinar to receive a certificate of participation, and then you can provide feedback on this webinar series as well. Again, thanks, Beth, for your presentation, and we hope you all have a good day today. Thank you.
Thank you.
Yeah, thanks, everyone.